Do you have any problems when milling aluminum? For example, long chips clogged in the workpiece. Bars are generated and it takes a lot of time to remove them. There are many cutting edges and so it takes a long time to adjust the height of all edges. Various problems might happen in aluminum milling.
This is Kinoshita from Sumitomo Electric. Sumitomo's PCD cutters for aluminum, ALNX, solves these problems. First, let's look at the solution for chip control. In such parts, the pieces would be scrapped if chips are clogged inside. ALNX can break chips into short pieces and solve this problem. ALNX passes coolant through the blade with a cutting edge, delivering coolant as close as possible to the cutting edge. We call this braid-through coolant. Oil hole has a vertically long shape along the cutting edge to optimize chip control. By making the distance from the oil hole to the cutting edge close to 5 mm, as opposed to the conventional design's 15 mm, the coolant is delivered to the cutting edge precisely. Chips are shown on the right when cutting under the same conditions. Chips machined by ALNX are broken into very small pieces. The internal structure of the cutter body is also optimized. This shows coolant flowing through the cutter body. By making oil supply port smaller than the supply hole, the discharge pressure is increased and the coolant effect can be maximized. This shows how coolant is actually being discharged. At high rotational speeds, conventional tools are unable to deliver coolant to the cutting edge. But as you can see, ALNX delivers coolant to the cutting edge precisely, even during high rotational speeds with its design. Using conventional cutters, chips are scattered in all directions, and they collect on sensors and enter gaps in the equipment, making it difficult to clean them. This caused various problems. ALNX has unique chip pocket in the blade, allowing chips to be controlled. Next, let's solve bars, which is major trouble when machining aluminum. Bars generated on the exit side of the feed are particularly problematic. This bar is caused by the tool being unable to cut the workpiece successfully, but the material is crushed instead. One way to inhibit bar is to control the chip thickness. Conventional tools tend to generate bars due to the thicker chip they create. On the other hand, ALNX has a double chamfered edge, a two-step chamfered form. This reduces the chip thickness and inhibits bar formation. The bar inhibiting double chamfered edge is applied to these four types of blades. The standard G-type, which is the first recommendation, can be used in a wide range of applications. If a large depth of cut is required, for such as a cast workpiece, the GX type with a long edge can be used. You can select blade types according to the application requirements. The simple construction of ALNX reduces the number of times required to adjust the height of the cutting edge. The procedure takes 3 steps. First, pre-tighten the blade. Next, adjust the cutting edge height with a wrench. Finally, free-tighten the blade. With the highly rigid cutter body, the height of the cutting edge remains unchanged after the blade is free-tightened, requiring the adjustment work to only be performed once. This greatly reduces the setting time. Let's look at the actual setup. Using a contactless presetter, adjust the cutting edge height according to the operation described earlier. Since we've already finished pre-tightening the blades, so we start from adjusting the height of the cutting edge. This figure indicates the position of the cutting edge height. Adjustment will be made by aiming at 95.2. You can see that the cutting edge height is raised when the wrench moves. We were able to easily adjust to the target value. Then tighten the screws to fix the blade height. The blade has been fully tightened, but the height of the cutting edge did not change from 95.2. Let's fast forward and adjust the rest of the blades. Since the cutter has 18 blades, we need to do the same operation 18 times. As you know, PCD milling cutters such as ALNX have many blades. If the blade position were to change after the blade is tightened, the cutter would need to be adjusted repeatedly, resulting in a very large loss of time. Setup is completed. When using ALNX, it is recommended that the blade height variation is 5 micron or less. By adjusting all the blades just once, we were able to adjust the height of the cutting edge with a variation of 3 micron relative to the target value of 95.2. ALNX offers a full lineup of cutter bodies and blade types. The cutter body has a tool diameter ranging from 25 mm to 160 mm. The number of blades can be selected from 3 types according to the application. We also offer a wide range of shapes, from face milling to modular for long overhang machining. For face milling that requires good surface finish, you can select one with fewer blades. For high efficiency machining, you can select one with larger number of blades. In addition to the 4 types of blades that have the double chamfered edge, we also offer a lineup of blades that allows corner radius machining and a wiper blade that stabilize the quality of the machined surface. The blades can also be reground by up to 1 mm. Even after being reground, the blade through coolant remains effective. How was the instruction of ALNX? In addition to the information presented this time, we can also provide specialized lightweight designs like this. For aluminum machining, please try ALNX. If you need assistance with any application, please contact Sumitomo. Thank you very much.